Photochemical smog. Photochemical smog is a type of air pollution formed through chemical reactions involving sunlight and pollutants like hydrocarbons and nitrogen oxides. Smog, a harmful atmospheric condition, is a blend of fog and smoke, leading to reduced visibility and respiratory issues. Smog is categorized into two main types, classical smog and photochemical smog, each with distinct formation processes and characteristics. Photochemical smog, also known as Los Angeles smog or summer smog, forms when sunlight reacts with atmospheric pollutants like hydrocarbons and nitrogen oxides. This brownish-gray haze, known as photochemical smog, predominantly affects urban areas with high automobile usage, causing severe health and environmental impacts. Photochemical smog is oxidizing and most noticeable in the morning and afternoon. It forms from primary pollutants like nitrogen oxides and volatile organic compounds, creating harmful secondary pollutants. In vehicles, nitrogen is fixed into nitric oxide. At high temperatures, a process explained by the Zeldovich mechanism. Rapid cooling prevents NO dissociation, contributing to smog formation. Nitrogen taken into engine for combustion get fixed at high temp in NO. It is a slow reaction and summarizes two simultaneous reaction known as Zeldovich mechanism. If effluent cooled slowly, the NO get dissociated, but in vehicles the cooling is rapid, giving very little opportunity for dissociation and nitrogen fixed in NO form. Nitrogen dioxide absorbs light energy, resulting in a reduction reaction. NO2 NO plus O3. The nitrogen in NO2 has an oxidation number of +4 and the nitrogen in NO is +2. In sunlight, atomic oxygen combines with oxygen gas to form ozone. O plus O2 O3 4. Reaction is temperature and sunlight dependent. NO and NO2 can also react with the hydrocarbons instead of ozone to form other volatile compounds known as pan-peroxyacetyl nitrate. The accumulation of ozone and volatile organic compounds along with the energy from the sun forms the brown, photochemical smog seen on hot sunny days. Nitric oxide NO and nitrogen dioxide, NO2, are emitted from the combustion of fossil fuels, along with being naturally emitted from things such as volcanoes and forest fires. When exposed to ultraviolet radiation, NO2 goes through a complex series of reactions with hydrocarbons to produce the components of photochemical smog, a mixture of ozone, nitric acid, aldehydes, peroxyacyl nitrates, PANs, and other secondary pollutants. Photochemical smog sources: vehicles emitting smoke, industries emitting smoke, volatile organic compound released from paints and adhesives, power plants, unburnt hydrocarbons, trees which emit isoprene and terpene. Photochemical smog causes ill effect on health. Both ozone and PAN act as eye irritants. Ozone and nitric oxide irritate the throat and nose. Their high concentration causes headache, dryness of the throat, chest pain, cough, reduces lungs function and difficulty in breathing. Photochemical smog leads to cracking of rubber and extensive damage to plant life and inhibit their growth. It also causes corrosion of metals, stones, building material, painted surfaces.